Okay, this is Jose Apena from Igalia. Today I'm going to talk about the work I've been doing with the Windows native stack profiling, and that is on the feature in this year. Okay, so first a definition. Core stack profiling, it's a performance analysis tool. Basically, it samples periodically the core stacks of all threads for a workload. Why? We want to get a better understanding of the CPU-bound performance problems. It provides a breakdown of the code that is exhausting CPU resources. It's good for initial analysis of the problem, but it also allows deep dives later. And also it allows to compare different implementations to understand the improvements and the regressions. So how does it work? First, on compilation stage, we need to generate the function information and frame pointers. And then on runtime stage, the JIT compilation is going to also generate function information. And the performance sampler will extract the core stack for all processes and threads periodically. Okay, so core stack profiling can benefit from system-wide sampling. So we want to include the system libraries and the dependencies and in the analysis. We want to integrate that with all the metrics provided by the system. Many CPU-bound problems are not constrained to a single component, so it's important that we get system-wide data. Okay, so how do we do the recording? First, we need to compile with enable profiling equal to true. This is a command line that could work for doing the captures. And for doing the actual recording, we can use Windows Performance Recorder or UI for ETW and recording session. About analysis, we can use the Windows Performance Analyzer. We need to have the paths for the PDB symbol files. We need to use the sample CPU profile view of the tool. So about this year work, first thing is that now it's working again. That's a regression that was there, it was not working, and now it works. So that's great. Okay, so these are the changes. Basically, one of the things is that now we can do stock walking independent of enabling interpreted frame stack, native frame stack integration. It's built by default, but there's no performance penalty when we are not profiling. Now it works also when Perfecto is enabled. The profiling performance have been improved significantly, and this is important. We generate far better method names, so it's easier to understand what we are tracing and what we are obtaining for the tool. So these are the main contributors for this year work. My work has been sponsored by Bloomberg, and it's available on V8 10.9. Thanks.
All right. Next up on stage, we'll have Yoav. It still takes like 15 clicks even when I'm doing it right. There we are.
Okay, and Ron. Oh, yeah, so hi, I'm Yoav, and I wanted to talk to you all about Gerrit in the case of the missing R+1. Basically, has this ever happened to you? You work on a CL that is complex and has multiple, requires multiple reviewers in multiple time zones. Then they provide feedback. You address that feedback. You actually get them to review that again. They +1 your CL, and then one less reviewer says, why don't you add this, I don't know, add a test or do this other thing that touches this extra file, and then that just resets all those votes and makes you sad, makes the reviewers sad. And I don't know about you, but it has happened to me multiple times. And the reason for that recent modification in Gerrit is security, and security is super important. But at the same time, this feels like it feels to me that this particular change could have been done slightly differently. From my perspective, the downsides here is that it feels like an overreaction. It disincentivizes CL modifications. So whenever like a reviewer comes in at a late stage saying, why don't we do this other thing? I just tend to, okay, I'll do that in a follow-up and push another CL. It slows down landing CLs. And one thing I saw recently, it is somewhat scary for new contributors that they already accumulated the courage to bug all these important people, and now they have to bug them again for them to click on a button. And that's not great. The upsides here is that if you're counting your productivity based on CL count, this is great. This is just, yeah, all those follow-ups really add up, and yeah. So maybe we can reconsider, and maybe if a new file is added to a CL, maybe we only need to reset the votes of the concerned reviewers and not of reviewers for completely unrelated files and directories. And with that said, yeah, thanks to the infra folks. Your work is incredibly important. I complain because I love. Thank you.
All right, up next in about 15 more clicks will be Ella. Oh, sorry, this one's going to be Ella. I have them in the wrong order. Nina? Yeah, thank you. Okay, I apologize, Ella. You'll be next.
Yeah, we should really improve this workflow.
Yeah, well, do what you do. Okay, it's coming up.
Hey, I'm Nia. I work at Google. I'm gonna talk about stuff. Password suck. You can probably imagine what I wrote there originally, and then I came up with the pun. And we all know why they suck. I don't have to go over this. The UX sucks. Having to memorize them sucks, and they're terrible for security. Nobody wants to see that dialogue over there. So just let's fix that. You know, why not? And let's fix that with something called Passkeys. So what are these Passkeys? So they're a pair of public private key credentials that you can register. When you register them, the private key gets stored in some device, and the public key goes to the server. And then when you want to sign in, instead of typing a password, there's some cryptographic dance, and your device verifies that it's you with like a fingerprint reader or something like that. Also, passkeys are a common noun, so no capitalization. And yeah, so passkeys work with lots of devices. If you have a machine that is not a Linux desktop, it probably works on it. So Apple, Windows, Android devices. If you have a Linux desktop, I have one. You can also use a security key. They're like these tiny USB things that you plug into them and then you tap them. Some of them have fingerprint readers too. And they are built on standards. And this is really good because it means you can use your iPhone to sign in on a website on your Windows machine. And the other way around, you can use your Android phone to sign in on your Apple machine. And they talk to each other using WebAuth and something else called FIDO, which is not part of the web, but it's kind of out there too. Passkeys also integrate with passwords. So if you're making a website and you're a little concerned about this new UI, well, you don't need any new UI. It just works with autofill, so you can like tap that button and have the user sign in. And also the user doesn't even have to know they're using a passkey, which is great. And also passkeys sync in the same ecosystem. And this is great for recovery. And also, like if you lose your phone and then you get another phone, well, as long as you sign in with your, say, Google account, or if you use a password manager, that support for that is coming later, then all your passkeys get synced again and you can sign into all the websites. Kind of the same as having a password manager. And they can probably work in the browser that you are building, although they may need special entitlements or permissions for security reasons. If you want to learn more, you can scan that QR code. It would be really cool if I was phishing and then I use that to like prove that passkeys are cool because they're unphishable, but no, it's not phishing. There's a link if you want to learn more, or you can email me. And yeah, applause. Thank you.
All right, now I got you, Phil. All right, so up next is Ella.
Thank you. Hi. Yeah. Hi, my name is Ella, and I'm from the Chrome mobile web install team. Oh, yeah.
This is my fault. There you go.
Right, perfect, thank you. Right, yeah, and yeah, I'm here to talk about some changes to the install criteria. And some of you might already know that right now, PW needs to meet a bunch of install criteria before Chrome allow users to install on the users' devices. Firstly, it needs a web app manifest for the brand of the web app, and secondly, it needs to have a functional service worker to provide offline capabilities. And the last one is some very, very basic user engagement. And these criteria were added many years ago to incentive developer to build high quality web app and use new features. But and also service worker is required because as an app, you need to have some basic offline experience. But what is still good in 2022? We are reconsidering that, and because this criteria are kind of like outdated and it created many trouble for developers. Therefore, we are making some changes. Okay. Starting from M105, Chrome Android no longer require web app to PWS to have a service worker to be able to install, and because of this, since this change landed, our install rate increased by 15%, and also there are 30% more distinct codes were able to install on users' devices. But what happened when the install web app is offline? Even though we all love the dyno, we don't want to see them because that's not what an app should look like. Therefore, starting from 108, Chrome Android started providing default offline experience. It's an auto-generated offline page that's incorporated with the style of the web app. And what it does is just to tell the user, hey, things are not working now because you're offline. It's a very simple page, but it's really easy developers hassle for making one of these offline experience themselves. Of course, this doesn't mean that we are getting rid of service worker. We still encourage developer to build a good offline experience by providing a service worker, but if they don't want to, they don't need to. And besides that, oops, I'm leaking. Besides that, can we do more than that? And we want install to be the user's choice, and we don't want to put install under. We want to put the install under user's control and stuff, so they can install everything they want. And so therefore, we are thinking of getting rid of the manifest requirement as well. We can get all the information from the web page itself and generating the APK accordingly. This allows users to install their favorite site, even though the developer didn't update their website to include meet to this install criteria, and also this will make install super easy for developers. And in the meanwhile, we don't want to over promoting the install. We want to make the user engagement the only and the most important, well, not only, but we want to make the user engagement the most important install criteria. We are looking into improving these user engagement criteria by learning from user behavior and engagement data. So we promote and explain the benefit of install to the user that can mostly benefit from installing the web app. All right, yeah, that's all for me. And there is a breakout session to discuss more on the install on Thursday, 11:05. Thank you all. Please join the breakout. Thank you.
Nice thing about everybody running just a little bit fast is this isn't actually slowing us down. Next up, by the way, will be Gyu Young. Take it away.
Hello, I'm Kyung Kim from earlier. In this session, I'm going to briefly introduce the WebGPU CTS. First, WebGPU is a new web API that exports modern computer graphics capabilities, specifically direct 3D on Windows, Meta on Mac, and BlinkOn on Linux, Chrome OS, and Android for performing rendering and computation operation on the GPUs. And Chromium aim to release the WebGPU around the beginning of the next year with a good performance test coverages. CTS is an abbreviation for components test sheet. It tests the behavior defined by the WebGPU specification, and the CTS written in TypeScript, and the WebGPU CTS has been developed in GitHub. The WebGPU CTS can be run with a sort of adapter layer to work on the other test infrastructure like web platform tests and telemetries. Currently, there are 1,400 tests, and the WebGPU CTS is arguably more important than the WebGPU specification itself because it was what forced implementation to be interoperable by checking they conform to the specification. There is a standalone CTS runner, so we can test a standalone test if we go to this site with enabling the web GPUs. Regarding the contribution, the testing tasks have been tracked in the CTS project runner. The procedure of adding a new test is below. First, you need to set up the CTS development environment and add or edit test plan in the CTS project and implement tests. Last, upload the test and request a review in the CTS GitHub project. The CTS is largely composed of the 4 categories. API is to test for full coverage of the JavaScript API surface of the web GPU. Shader is to test for full coverage of the shader that can be passed to the web GPUs. IDEA is to check that the GPU IDEA is correctly implemented. Lastly, web platform test for web platform specific interactions. This is a simple test for checking the writable validations. Basically, the general test consists of the 3 blocks. DSC describes what it tests and summarizes how it tests the functionalities. Params defines a parameter with a list of objects to be tested. FN is the implementation body of the test. Take a look at the parameterization of it differs. The CTS provides helper params and branch helpers for creating large Cartesian product of the test parameters. These generate the test case further subdivided into test subcase. Thanks to the parameterization support, we can test with more various input values. So CTS project has been developed by a dozen of contributors. This table shows the key contributors classified the email account. Igalia has been participating in the CTS project since this June. Thank you for listening, and I appreciate Ken Russell and Kai Ninomiya who have reviewed my task. That's it.
Next up on stage will be Zachary Tan. Close this down. There we go. There you are, sir.
Thank you.
Hi, my name is Zach. I'm an engineer on Google Chrome, and today I'll be talking about multiple identity provider support on FedCM. The next button. Oops, I clicked it a few times more. Okay. All right. In 1994, the cookie was developed. The cookie on the web, not for food. It was used extensively on the web to store all kinds of data. In 2019, Chrome announces the Privacy Sandbox, which is an industry-wide effort to improve user privacy across the web. In 2020, the initial plans to phase out third-party cookies were announced, and currently the plan is to phase it out in third quarter of 2024. Some of you may have seen this before, not the elections, but the dialog box on the top right. So the New York Times, in this case, is more than just a newspaper. It is what we call a relying party, and that relies on Google, in this case, more than just a search engine, which is what we call an identity provider, in short, IDP. This provides the user an account without requiring a new username and password. This is known as identity federation, and parts of it depends on stuff like iframes, redirects, and cookies. On top of that, the current sign-in button flow requires a lot of top-level redirects where you're redirected away and then back to it, and this may break in the future, and this is where FedCM comes into play. So you put 2 and 2 together, cookies are being phased out, parts of identity federation depends on cookies, and that breaks a bunch of stuff, so this is where the FedCM API comes in. The FedCM API was launched in M108. It provides an abstraction for federated identity flows on the web. It does this by exposing browser-mediated dialogue that allows users to choose accounts of IDPs, such as Google. The existence of the FedCM API also gives us many opportunities to revamp how federated sign-in would work in the future. So today you may have seen buttons like these, continue with Google, Facebook, Apple. So the New York Times has to show you all 3 buttons, regardless of whether or not you have an account with any of these. If you're long, short, fat, tall, thin, you still get the same 3 buttons. And this creates what we call the NASCAR problem, which is there is so many icons on the website. It looks like a NASCAR race car. FedCM can do better by being more opinionated and showing more prominently IDPs that you have accounts with. In this illustrative mock, you can see that the user has active web sessions with both Facebook and Google, but they can also choose to use other IDPs or accounts. We currently have a desktop implementation of multi-IDP support available behind the flag in M108. That's the first implementation. The flag is as follows, and the demo site is on a later slide. So please note, we're still working towards finalizing the API design. If you'd like to learn more about FedCM or multi-IDP, we have a link tree which contains a bunch of stuff. It has a blog post, a demo site, a public GitHub repo where a lot of the details and discussion occur there. If you'd like to catch us in real time, we have a breakout session later today at 1:40 p.m. But if you can't make it later today, we're also very heavily involved in the Federated Identity Community Group, which meets on most weeks. Thank you.
All right, next up will be Youngsu. Did I close the meet? Lol, I did. What? No, that's just the normal thing. Cool, 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 cool. Here we go. Everything's fine. Nothing's wrong. We are ahead of time anyway. Yes, this is the one I want. All right, take it away.
Okay, hi, I'm Young-Soo Che from LG Electronics. Today, I'm going to talk about the Wayland part of the ozone layer in Chromium and how it is used in LG WebOS platform. So LG WebOS platform is LG-owned web platform, which is used on various LG devices. And this is really a brief architecture of the WebOS, but I'm not going to give any details on here. But I just want to point out that Chromium is used as the web runtime system in WebOS platform. And WebOS is using the Wayland protocol for the graphics window management system and the input event handling. So to use Chromium in WebOS, we needed an ozone Wayland implementation. But when we tried to use Chromium, there was no generic ozone Wayland implementation at that time. So we needed another solution for it. And we chosen the open source ozone Wayland implementation, which was developed by Intel. And yeah, it was good. We used it for a long time, like more than 7 years. But the only problem was that the open source itself was deprecated. So we had to maintain ourselves. However, since the Wayland have become very popular in the industry, Chromium also have had a discussion to support the ozone Wayland implementation. And after several milestones, finally, currently, Chromium had also implemented the ozone Wayland. And WebOS also switched to this Chromium internal ozone Wayland implementation from Intel ozone Wayland implementation. So this is a brief architecture of Intel ozone Wayland. And this is the Chromium internal ozone Wayland. And basically, there's not much difference in the architecture. But if we compare those two, I think the major benefit is that Chromium ozone Wayland supports GBM, which could be really powerful. And Intel ozone Wayland have very flexible architecture, so we can easily adapt third-party Wayland protocols. So I really want to appreciate all the persons who is related to the ozone Wayland implementations, and thank you for listening.
All right, next up in a moment will be Andrew. Now, we've been on presenter view though, and this is, oh, perfect, it worked. Yay. All right, go for it.
Okay, so you know the text overflow ellipsis property, right? Unless you clip text in the that overflows in the inline direction and shows an ellipsis to indicate that it's clipped, right? And since for a long time, web developers have wanted something similar, but for text overflow in the blog direction. And in 2009, WebKit implemented the WebKit line clamp property. It takes a number of lines, not a hide, but we'll come back to that. But by itself, the property does nothing. You need these other two properties, which are all versions of Flex self. And what it does is it sets the intrinsic height of the box to fit the 3 lines and adds an ellipsis on the 3rd line, but the rest of the text still overflows. So you need overflow hidden to hide them. My name is Andrea Botella. I work at Igalia, and I'm helping an improved version of line clamp without these problems get specified and implemented in Blink. This work is sponsored by Bloomberg, who is a heavy user of web line clamp and cares about improving it in the web platform in general and in Chromium in particular. So currently there is a version of line clamp in the specs. You can check out the link for the specs. It fixes the overflow hidden problem, and it's based on fragmentation. Fragmentation is the way you take web content and print it, like fragment it into pages for printing, for example. And actually, line clamp is a shorthand property. So continue discard makes the box into a fragmentation context. And hides anything but after the first page. Max lines 3 cuts, like inserts a forced page break after the 3rd line, and block ellipsis auto adds an ellipsis on every page but the last, like at the end of every page but the last, more or less. And with this, you can actually achieve a height baseline clamp if you set a height and remove max lines. The fragmentation works fine. And so let's ship this, right? So with layout energy, you don't actually need to lay out pages after that will be discarded. You don't need to do the layout for that. But interacting with legacy, you still need the full layout for reasons. And in 1.8, nothing uses legacy anymore, and we're working on this. You can check out those links. But like implementing this will still take months, and other browsers are far behind on fragmentation, and they won't be shipping this in a reasonable amount of time. So in TPAC 2 months ago, Emilio from Mozilla had an alternative proposal that just doesn't paint anything after the clamp lines, and it treats everything as if they didn't take up space. You still support high base clamping, but I won't get on it. This is a hack, okay? But it's much easier to implement across browsers. It could take like 2 weeks to implement in Chrome, and it has nicer properties for scripting. So there are a number of open issues, which you can see at this link, that have to be resolved before this can be spec'd. But once it's done, yeah, it might take two weeks to implement in Blink and not have like it would be similar to the fragmentation-based version. But if we go back to fragmentation for a second, like the line clamp short long hands seem like a first step to allow things like broken flows of text, like continued on page 2. So how about we, rather than remove it, we use continue discard for fragmentation as soon as it's available when it's shipped. Continue collapse, you would use this new model, and you can opt into fragmentation with line clamp 3 continue discard, right? Thank you very much.
All right, coming up next will be Addy. Wait, are they in person? Ada Nilsson? Oh, yeah, there you go. Make sure we do have one remote presenter today. I was making sure there wasn't more. Not a problem, not a problem. And there we go.
All right, thanks. Well, lots of lights. Hey, hi. So my name is Edenilson Cavalcante. I'm based at the San Francisco Bay Area, currently working for Intel, previously for ARM. Right, so today we're going to be discussing Z news from Zlib. Okay, right. So the objective is to share the maintenance work we have done the last 6 months and report performance improvements. A little bit of context. Chromium has a heavily patched Zlib. Zlib is a data compression library, and the fork of Zlib we maintain is used by AOSP, V8, Chromium, Node.js, and recently by Google itself. Right, so it's heavily optimized using Cindy, so we can have up to 3 times faster data decompression and plus 30% compression in average. And it's been in development since 2017, so we're about to complete 6 years already. All right, so let's start with security. So last August, a CV was found in Zlib, was scored as 9.8 critical. But the good news are in the whole Chromium code base, we don't use the impacted API, which would be in flat get header. Basically, if you had like a properly crafted payload and call this API, you could have a buffer overflow. Anyway, we fixed it and was backported the fix all the way to M104. And there is what looks like when you run a ozone build and run the payload. And we even have a fuzzer now that was contributed by Hans van Borg. Right. Also, Canonical Zlib, which is like the mainstream Zlib, they made a release in October 13th. We were partially in sync with their development branch, and we completed the sync in November 7th. Basically, the previous sync had to deal with 5 years of patches, because that was the time that took between release for Zlib. But this time, because we were partly in sync, that was much easier. And I'd like to say thanks to Chris Bloom. He's a retired Google engineer, as also Noel Gordon and Hans van Borg for reviewing the patches. Next, speed. So we landed a patch that uses the polynomial multiplication instruction on ARMv8 to speed up data decompression. That benefits a lot the M1 processor, and we can have up to 13 faster data decompression for HTML content. Finally, there is a new player. Doug Johnson has been doing some amazing research on optimizing Zlib, and we have started the work to port his optimizations to Chromium Zlib. The first patch was a flatter Huffman table. The basic idea is that you have a bigger root table, so you avoid some branch mispredictions when you are performing lookups in the table for the next Huffman code. That comes with a memory price, about 1.9 kilobytes, but there is an average gain of 5% for Haswell and 8.3% for ARM Cortex-X1 that landed in September. Keep in mind that we are already like close to 3 times faster. Trying to optimize something that is already optimized is harder. Right, compression. I have a patch that is work in progress. Basically, we replaced the hash we use today for performing compression using a new multiplicative hash suggested by Noel Gordon, who works for Google. So the average gains is like close to 30% for Tiger Lake, 20% in average for X1, and 18% for the M1. What is missing to actually land the patch that you guys know. Sometimes we have like some pixel tests, they are failing, and then you have to update the test expectations. But that's like just like lots of work, but it's not like challenge at all. Finally, Chromium Zlib is a never-ending journey because it's really interesting. When I started work on it, like in January 2017, I was sure I could get the work done in 6 months, right? But next January is going to be 6 years work on it. And by the way, we have a breakout session the last day of the event So people who is going to be around, I have some really exciting news about using hardware acceleration. And basically, if you guys want to contribute patches are always welcome. And that's it.
Our next speaker will be Joey. Okay. Real quick, did you do something weird with your slides?
Oh, that's the, can you go to the sheet? The link in the sheet should be good.
I have an old sheet apparently.
Oh,
Oh no. Unless it's this one. It's probably this one.
I moved it to my Chromium account. The first one was my Google account, and then I was like, oh, it says I'm supposed to make it public. So then I moved it. And
Got it. Oh, here we go. Okay, I think this is good. This is the one I want. Nope, not that one. This is the one I want. Take it away.
Hey everyone, my name is Joey. I work on the DOM team at Google, and today I'm going to talk to you about my project to improve event dispatching on disabled form controls. So, the disabled attribute, some of you may have heard of it. You can put it on a form control element, and it makes it like not focusable, editable, clickable, or anything. It gives it this kind of grayed out appearance. Pretty straightforward, right? Or so you would think. So, the first quirk I want to talk about is the mouse event quirk. So disabled form controls don't get click events dispatched on them, and this is important to prevent like activation behavior, like submitting forms and stuff. And this is like, what we want to do with disabled, but unfortunately this behavior is applied to all mouse events. So like mouse move, mouse over, and like a ton of other stuff, they don't get dispatched on disabled form controls. And this was highlighted by our good friend, Jake Archibald, in this article written in 2017, which actually shows that it's like a browser compat issue. Like every browser kind of does something a little different. And the next issue is the event path quirk. So you can see the left and right. I have two very similar disabled buttons. So the one on the left is a button with no children. It just has some text. The one on the right is a button with a child element. So if you click on both of them, on the left one, you just click on the button element directly, and no click event will get dispatched to the button or any of its ancestors. However, on the right, if we click on that child div there, the child will get a click event. The button will not get a click event. It's sort of like skipped in the event path, and then all of the button's ancestors also get click events. So pretty weird that, depending on if you have a child element, we get like different behavior for the ancestors. And it gets really weird with input events, or input elements, I mean. So input elements have a user agent shadow root. So when you click on it, you're technically clicking on a div that's inside the input. And so like the ancestors of the input will always get all the click events. And we don't really want this behavior. We want it to be like the same across, all the different disabled form controls, whether they have children or not, or shadow roots or anything. And this has caused a variety of different Chrome bugs and spec issues. And after discussing on the spec issues for a while, we decided on some new behavior. So we're going to fire all mouse events except click, mouse up, and mouse down on disabled form controls. And then we're also going to stop propagating any of these click, mouse up, or mouse down events when they get to the disabled form control. So it'll never hit any of the ancestors. But it is still going to go through the child elements, and this is the same behavior that Firefox has. And I'm going to start rolling this out in Chrome 110, and hopefully it doesn't break any websites, but if it does, I've created an enterprise policy and have it all ready to be disabled to Finch, and hopefully we can land with something that is interoperable and that web developers like. That's it.
All right. Next up, we have Max. Take it away.
All right. Hi, everyone. I'm Max. I'm part of Egalia's Chromium team, and I want to share a bit of my work that I did on fallback tab dragging for ozone Wayland. So first of all, let's recap how tab dragging should usually look like. This was recorded on X11. You can... Nope.
I think inline videos are funky. Let's see if I can do it not in the presenter view. Give me a second. I have to represent this. Oh, over here.
All right, great. Thank you. You can see that you can drag tabs out of a window and it detaches into a new window that moves together with the mouse while you drag it. Sadly, this does not work on Wayland currently. Instead, it looks like this. The new window just opens somewhere on the screen. It does not move together with the mouse while you drag it. And if you merge it back into another window, it just disappears again. This is not great UX. And there also have been some crashes because of tab dragging on Wayland. So why doesn't it work on Wayland? There's mainly two reasons. The first reason is that Wayland clients don't know about global screen coordinates. They only get service local coordinates relative to their own windows. And also Wayland client can't control the window position on their own. There's really strict rules that are enforced by the compositor. And together, these two reasons mean that we can't move the window that contains the detached tabs with the cursor while dragging. You can make this work just as on any other platform by extending the Wayland protocol, which is what a colleague of mine, Nick Diego, did. He wrote the extended drag protocol extension, which extends the regular drag and drop capabilities to implement this tab dragging. The only drawback is this is currently only supported by EXO, so we need some form of fallback for all the other compositors. This is where I come in. I implemented what I call fallback tab dragging. Looks like this. The idea is that we don't create a new window until the user releases the mouse. And to signal that there's something going on, we just show a little drag icon. So in theory, it's really simple. In practice, it's been quite complicated to integrate this well into the big tab dragging state machine. So we definitely need to test this. However, there's some problems because input emulation doesn't really work well on Wayland as soon as there are multiple browser windows are open, which is kind of central to tab dragging tests. So to fix this and some other issues, I'm working on a new Wayland testing protocol extension together with help from Google's Lacrosse UI team. And as soon that's landed and implemented, hopefully we can ship fallback tab dragging by default. Until then, it's behind a feature flag. You can test it out yourself if you want to. Thanks to these people for reviewing my patches and helping with the design, and thank you.
Next up will be Antonio. Yeah, here we go.
So hello everyone, I am Antonio from Igalia, and I'll try to give a quick overview about the Lacrosse and the Ozone Wayland projects. And basically, one important thing here is that all the work that we've been doing upstream actually started off of a discussion that we've took place here in BlinkOn 2017, it was BlinkOn 7 with some Intel folks, some guys from Igalia and some guys from Google as well. So that's why the networking here is so important. And after that, we've been giving some updates to the community on many BlinkOns. And what I want to show here is how two different words actually got connected and became a new project. So basically, in one hand, we have the Chrome OS ecosystem, and here we have various Chromebook devices and various Chromebook vendors and all this. And for us to understand, I want to pay attention to three main concepts here. The first one is that on Chrome OS, the system UI, including the window manager, the login screen, and the web browser itself, they are on the same binary. So whenever it crashes, actually the whole system goes down and up. So that's one thing. And there is also another key concept. It's Ash, the window manager itself, and ESO, which is the built-in Wayland compositor that ships today in Chrome OS. So these three things are going to come up later on. And on the other hand, we have Linux desktop that was already introduced by Young-Soo earlier on. And basically on Chromium, on Linux, we have Chromium running on top of this abstraction layer named Ozone. And it basically wraps actual platform and desktop environment interfaces. On desktop Linux, again, it defaults to X11 Ozone, and users can opt in to Wayland today. So what Lacrosse is actually in practice, basically we have Chrome OS with a built-in Wayland compositor named ESO, and we have a Wayland Chromium application that we are making running on Chrome OS on top of this ESO compositor. So basically we're bringing two words together and launching a brand new project. Igalia has been involved on this in various aspects, together some other Google folks, including the look and feel, like rounded corners, frame decoration, tab dragging, as Max said, and window manager integration on desktop and on Chrome OS. We also have, from the beginning, handling gestures, input overhaul, including stylus. We've also worked with some miscellaneous web UI fixes, tablet mode fixes. In graphics land, we've implemented or helped with the delegated compositing feature, overlays, IME, stability, RNS, and all this stuff. So we've been doing a lot, and this is in practice how in one side you see Lacrosse fully integrated with the Chrome OS environment, and a raw Chromium Wayland also running on Chrome OS. So they look different, but they are actually the same source base in practice. If you want to help us to, test it out, just go on your Linux desktop and enable the Wayland backend. If you are on Chrome OS, just enable Lacrosse and you can file bugs and all this. And that's it. Thank you very much.
And our final lightning talk for the day will be live but remote. It'll be done by Jean. Stop sharing. Now, Jean, are you able to?
Yes, I'm just going to present my tab. Yay. There we go.
Now, can we make this louder?
I can speak up.
Perfect. No, we got it.
Okay, awesome. So I wanted to give everyone an update on scroll linked animations, formerly known as scroll timeline, but it's been expanded slightly over the last little bit. It's been a very busy year for this standard, and really happy with a lot of progress that's going on. Thought I'd give everybody an overview. So first of all, the spec. It has kind of gone through 3 iterations, and they've not really all been named, but I do consider them different eras. The first spec was great. We prototyped it, and then we did an origin trial with the folks from AMP, and they said, hey, we like that spec, but we'd really love it if we could define a scroll timeline that's based on objects that are scrolling through the field, because that's a lot better. So we iterated on that, did another version of the spec, did another version of the implementation. We went out and back in December, last December, we got feedback from the CSS working group saying, oh, we love this API, except we wish we could actually code it in CSS. And there was CSS there before, but it really wasn't thoughtfully done. So we've done a whole bunch of work this year to bring the CSS first concept forward. And we currently have an API that we're really happy and proud of. It has matured over the 6 or so years that we have been implementing it, was featured in Chrometober, which is DevRel's outreach to say, hey, there's all kinds of cool APIs I've been working on. All of these animations that you're seeing in this goofy little video is, sorry, goofy because I'm showing a video of a web page. It's a nice web page. But all of those animations that are going on there are powered by scroll linked animations along with snapping, and there's a lot of cool stuff. The building Chrometober gives a really good deep dive into all of the overviews of how the APIs work and how you would use it. And all of that Chrometober event, it also highlighted a whole bunch of other cool APIs that have come out. So if you haven't seen it yet, I'd encourage everybody to go over and take a look at it. But the cool thing there was that it was implemented using our polyfill. So that means that it's usable in every major browser on every major device, which is a very cool thing to be able to do that on a spec that is not yet ready for release. The next thing I'll say is the polyfill, which is a big deal, actually. We've invested a lot of time and energy in the polyfill, and the reason that we do that is, well, multiple reasons. First of all, when you bring a polyfill, you can do a demo that actually is a demo written in the actual API. And that really helps drive the spec conversations forward. When people are complaining about something in the API, they can code it up and show you where the pain points are. And it really does help drive spec discussions. Next is interop. We know that it'll take a long time for this API to roll out into every major browser. So people who want to experiment can do that right now with a polyfill. This polyfill happens to be very performant because it does a fairly good job on most other browsers. It uses some JavaScript, which means it's a little slower than doing everything in the compositor like a native implementation, but it's still quite usable. The other thing that we've done with the current polyfill is that we're now testing it against WPT. One of the big things, if an early adopter is going to use a polyfill, they have to figure out, will it work for all of the people that I care about? And so what we're doing is we are testing the polyfill itself against the published WPT. That, for one thing, helps us test our WPT really early, but it also helps us see that the polyfill is doing a good job, and it tells people that the polyfill is working on all the browsers. Whoops. And specifically, this is our testing from the polyfill right now. You can see that through the magic of GitHub Actions and Browser Stack, we are able to test WPT on Chrome iOS and on Android, on Firefox. All of this is just through the magic of Browser Stack. And this is the first time that WPT can be robustly tested on iOS. And when we talk about interop, people are trying to figure out if they're going to use your polyfill, they really mean, can I use it on my iPhone? So that is brilliant that we were able to get that happening. There's also a whole bunch of development work going on, so we won't get into a whole lot of that, but thank you so much for all the people. Anders and Kevin are doing a lot of great work along with Mehdi and Rob, and a whole bunch of other people. This has been a cast of many. It is a 6-year project. I have probably left somebody off of this. Oh, specifically the CSS working group. They have given a whole bunch of really good feedback this year. And I think that's all. You can clap if you didn't already.